dear colleague, Edwin. Yes, our outline will be start by the introduction, the purpose of the study, the project statement, the objective of the project, the project design and the implementation, simulation model, practical model, and demonstration. The result, as well, the problem encounter and solution. The lesson that we learned about this project, the recommendation, the conclusion, and the reference. Of course, all your questions will be welcome. I will call my dear colleague now to take over from me.
Thank you, Mr. Vaal. Ladies and gentlemen, thank you for making yourself available in this lab. I'm sure you're all asking yourself, what is this project all about? Or what this project is all about? As you can see here, the question says, what is an uninterrupted smart grid power supply and how does it work? An uninterrupted smart grid power supply, it is an electricity supply chain that combines non-renewable energy and renewable energy. In this case, we have a solar, a battery, and generator, and there is storm power, meaning both non-renewable and renewable energy. The purpose of the study. The purpose of this study is to evaluate, propose, and design an auxiliary power supply system interconnected in such a way that it allows both non-renewable and renewable energy to be working together. The problem statement. We are living here in South Africa, all of us. We've all witnessed load shedding, frequent power cuts, and so forth. So the moment when the demographic or the population grows denser, there is a problem with load shedding, frequent power cuts, and areas are affected. So this project is all about solving that solution. It's all about solving those problems. Moving on. The objective of this project, the specific research of this project, or the aim of this project, is to encounter those problems that we are experiencing, meaning that this is the only solution. The scope of the study, together with the limitation, we're only going to focus on an alternative power supply, meaning that if you have any other question other than alternative power supply, we don't have to answer it because of limited time. I'll hand it over to my partner, Mr. Da.
Yes, guys. Here is where we start. Everything starts with the paper, right? So we first grow our project. We first grow our project in the paper. Then the project of the paper end, but also the physical project here. So the project has three main supply: the ESCOM supply, the generator, the ESCOM supply, the generator, the solar energy, and which will be charging the battery. We already learned about the application of inverter and converter, and rectifier. We convert all those knowledge to attain our project. We use the contactor to make the circuit automatic. Like if one supply is go, the other can play the role. Now is the simulation model. Nowadays, the computer is one of the best things to lower the price of any project. So we decide, or we find this smart software to help us to do our project, the course of our project. Here is the simulation model. We got the bridge rectifier. We use the transistor and the switch. simulate to see the waveform of the output. Practical models and demonstrations. Guys, just give me just 1 minute to show you how the project works.
Thank you, ladies and gentlemen. As you can, we need all of you to visualize this project. Here we have the solar. The main purpose of this solar is to charge our grid. Here we have the converter, or some people they call it a rectifier, some people they call it the power supply. It also charges our grid and it takes power from its own power. Here we have our inverter to invert DC into AC to go to our grid. And then here we have our tester coil. The main purpose of this tester coil is just a load. The reason we made this coil is to honor the Nikola Tesla, or motivate our best guy. And here, in terms of protection, because you're asking yourself, maybe this is a bomb and everything. No, don't worry. We are having circuit breakers here. Even our load here, if you want to plug something, there is air connection. For in terms of protection, you are safe, guys. You don't have to be worried. And then here we are having contactors. This is where the main thing is here. You understand? This is an automatic switch transfer. Some people they call it ATS. So if you want to do this at your home or wherever, you can call us. There is no need for buying because it's expensive. And then here we are having our inputs and then we are getting our load. Then we test our project now. Now this is the ESCOM power. You can see it goes on, now it goes off. And now we bring the generator. This part will simulate the generator because of course we can't bring the generator. This part is for the generator. This one is for ESCOM power. It goes off. Now this one is for the generator. See? It goes on. There is a timer there. It goes off. Then this part is from the battery. Okay, it goes off. We have batteries. We know that in practical knowledge, if you can combine this power system to be a bulb, you only need this thing. So we're going to switch everything. Then we start with ESCOM power. It goes on. Now the generator, it comes in. Now we bring our battery. It comes in. Therefore, we need to switch off here. Actually, we are simulating as if ESCOM power up due to the chain or frequent power cuts and so on. So in this case, this load shouldn't be interrupted. So the ESCOM power will go off. It's still on. Now it's the generator. So now the generator needs to go on. This thing should remain on. Now the generator goes off. It's still on. Now it's the battery coming in. Now let's see if it's true it's the battery. See, it goes off. There's a battery, but it's better to power it to now, let's just say now you're using your batteries because the battery know that they are not efficient. Now the ESCOM power decides to come back. This thing shouldn't be tricky. And we need to save money and stuff. Let's see. Now the ESCOM comes back. Works very well. That's how it is. And you have that's not the power supply. Now, last thing. This is the bonus for you guys. We call it Tesla coil. As we said, we call our name Nikola Tesla. This light bulb, as you can see, this is not a magic. It will emit without any wires connected to it. Now you can watch. See, it goes on. No wires connected. I don't have magic. My partner can do it. Touch it. See, it's working. Just touch it. Yes, it's working.
I think we have to know where this is coming from. That's the result of our project. The description, as you can see, we got the measure, the V in, the current in, the power, the voltage out, the current out, and the power out, the frequency as well. Yeah, the result, you can see that they are slightly different, but with just some different. This can be a result of the losses from the input to the output. So I will call my colleague to take over.
Thank you. When we were designing this project, we gathered so many problems, especially on the part of the inverter, because if you are using DC and then you want to bring DC to the AC, meaning to the grid, there is one thing that you need to make sure that it's there. The frequency needs to be 50 Hz. If it's not 50 Hz here, then you go to a grid government. So we had a problem with the frequency, Then we tried to improve the frequency stuff, but we also had a problem with the under voltage, meaning that that's when we realized that things like power factor correction and so forth are important. We also had a short circuit. That's when we came to our mentor, countless time trying to fix it. Then he's the one who was trying to tell us how to achieve it. Then another problem was finding the right components when going to the shop. But other than that, we had solutions because we wanted to see it. The lessons learned, we learned that frequency is very important in the AC grid. And then the nameplates, the nameplates that you see, like things like contactors, when they tell you that this thing can work under the frequency of 50 Hertz, 2 volts is very important because if you supply the voltage with a different frequency, the contactor will just make enough sound. So moving on, recommendations. This power grid can be controlled by a PLC or computer program if you want to be automatic. The best way to do this thing is to do it in 3-phase. Another one, you can add more renewable or non-renewable energies. When you add another power supply, just add conductors and so forth. And then you can design a bigger tester coil to have a brighter illumination, so to say. So we recommend that UT should actually come up with a way of including solar supply into the grid. We want to make sure, we want to see after 5 years, we are telling you, after 5 years, we want to see every parking slot here having a solar on top. Instead of just putting a metal, just put a solar and then supply all the lamps. That's what we want. And for this project, it actually needs someone who's well trained to understand the whole thing. If you are not well trained, you won't be able to. So let me over to my friends.
Coming to the conclusion, the smart grid is a solution. Guys, you can all see that this is the solution of agile connection. Because we come up with a green connection, we will not going to experience anymore the load shedding in some problem, some power supply problem. So this is the solution. And again, this is 100% electrical. You can see we use some electronics stuff, power stuff, and here's the project. It's very well. So we can say that the project is 100% successful. By the we are maintaining our mentor to take out through this project, and Mr. Nico, who make himself available, and Dr. Amendek from the electronic department. To get more about, or to take all what you said there, yes, the references of our research. And of course, if you've got any question, it will be welcome.
Any questions?
Thank you. That's even there.
Someone had a question.
Yeah, we great for the two. What
I just wanted to ask, how does that magic work?
that magic? Yeah, sometimes we say magic coming from what people know. It's not the magic. This is the combination. Yeah, we make a circuit whereby this is a wire, right? From the output of the transformer, we got voltage which from the input of the transformer or low voltage. We got a high voltage here, right? Now, if I can touch it, it doesn't because there are no current. The voltage that works here. It's a max of voltage here. So we get the fluorescent.
I want to know which smart software did you use to do the simulation?
Yeah. Okay, we used NI simulation, the one we used for the design system. And my friend, to clarify something on that one, this tester code is called the resonant transformer. So the only thing that is that in a transformer, if you want the voltage from the transformer, you know the formula for calculating the EMF of the transformer, right? Is the change, it is the number of turns, d flux over dt. So in this case, the only thing that is happening here is just the rapid change of the magnetic flux that excites the element or the gases that they use inside the fluorescent lamp. So they get excited and they use illumination. It's just the magnetic flux. Woo! Oh, okay. Oh, okay. The whole project, I think, total cost 13,445. Yes. But with the help of our mentor, we managed to recycle some of the things that's what we used. But eliminating the transformer, the generator was 6,500, so we can eliminate that transformer.
Because we need also use the oscillator to check the
perimeter second.
How can we use how can this measure capacity? What can we use it for?
Okay, you can actually use it for anything. The thing is, when Nikola Tesla came with this idea, the problem was that they knew that if they can give people power or electricity wirelessly, they won't be able to charge them. So it will be free. So in that case, they actually demolish these things. So we can do these things if you want. But it means we have to change all the devices that are around here to fit or to meet the standard of this one.
Yeah, again, if you want to know more, then go in my voltage, get there. You see that big thing.